Hello world, this is the CS50x quiz show, the first ever, and we're about to begin with a 20-question quiz with hundreds of people around the world, all of whom have pulled up a multiple response form on their phone or laptop or desktop. And now, the first question. Over to Brian.
All right, let's start with a bit of a practice question just to make sure we're all used to the interface and giving responses. Question number 1 is, have you attended one of CS50's Zoom sessions before? So one of our classes or one of our office hours via Zoom. In a moment, you'll see yes or no, and whether you've attended or not, just hit yes for if you have and no if you haven't. So right now, you should now see options for yes and no, where you can now respond. And you have 30 seconds in order to respond to each of those questions. You'll be given more credit for the faster you're able to provide a correct response. Of course, for this practice question, either response is totally okay. All right, so time's up for question 1. It turns out that 65% of people have attended one of our sessions before, 35% of people have not. In this case, both answers were correct, so you'll get points for regardless of which one of those two you responded with. And let's do one more practice question, just to make sure we're all ready.
All right, the second question is, what continent are you on? Another opportunity for quite a few points. What continent are you on? You should see 7 options in front of you on your phone or laptop or desktop. Go ahead and buzz in. You have 26 or so seconds to answer this question. All right, with 0 seconds up, we're about to see the responses. You'll now see a distribution of everyone. So it seems we have quite a few people from Asia, followed by North America, Europe, South America, Africa, and sadly, no one from Antarctica could join us here today, but hopefully next time we do this together. All right, Brian, now for the first CS50 question. After taking a look at where everyone is, everyone, of course, is pretty much tied with 1,000 or 2,000 points at this point. And if you see on this leaderboard your number, that is how you can see how you rank. But of course, we'll only see the top 10 or so as we proceed. All right, Brian, shall we dive in for real?
All right, let's dive in for real. So the first real CS50 question then is, one of CS50's first problem sets has you implement a pyramid from what game? Your options are Pikachu, Mario, Sonic the Hedgehog, Princess Zelda. 30 seconds to answer this question. One of CS50's first problem sets has you implement a pyramid from which game?
If you've not taken CS50 before, we call our homework assignments or programming assignments problem sets in Harvard parlance. And indeed, one of the very first ones has you implement a game.
And all right, it looks like 93% of people gave the correct answer, which in this case is Mario. You might recall the first of CS50's problem set 1 in CS50, where you're asked to build using hash marks a recreation of Mario's pyramid in problem set 1. So Mario was in fact the correct answer. Here's our leaderboard after those questions. Looks like quite a few people with 3,000 points at this point. And let's go ahead and move on then to the next question.
All right, number 4. How would we represent the number 13 in binary? How would we represent the decimal number 13 in binary? You have 4 options in front of you. All right, time's just about up. Let's go ahead and take a look at the distribution of answers. So quite a few of you buzzed in correctly with 1101. And then a few of you spread out among the other answers. But I think for this one, why don't we go ahead to an official explanation of the author of this problem. Connor, would you like to walk us through why 1101 is right?
Yeah, I would love to. So if you'll recall from one of the first lectures in CS50, if maybe the first lecture, when computers store numbers, they store them in binary. So just like when we count, we use base 10, meaning the rightmost digit is multiplied by 1, the second to rightmost multiplied by 10, and 100, and 1,000, and so on. In binary, we do the same thing, but instead of 1, 10, 100, we go 1, 2, 4, 8, and so on. So in this 4-digit number here, we multiply the leftmost digit, which in this case is a 1, by 8, and then the next digit by 4, the next digit after that by 2, and the last digit by 1. And then when we add all of those products together, we get 8 plus 4 plus 1, which is 13.
So a very lucky number for 75 or so % of you, an unlucky number for perhaps some. Let's take a look now at the leaderboard. A whole bunch of people have now gotten all 4 questions thus far correct. And let's now transition to question 5. Over to Brian.
All right, it's time now for question number 5. Question 5 is, what problem might occur if a program tries to count to infinity as by incrementing the value of a variable again and again? Options are memory leak, stack overflow, floating point imprecision, or integer overflow. What problem might occur if a program tries to count to infinity as by incrementing the value of a variable again and again? You have 15 more seconds to provide your response to this question.
Recall from the start of CS50, you might have seen a sheep doing this in the context of MIT's Scratch at one point.
All right, time's up. Let's take a look at the responses. It looks like 34% of people were able to give the correct answer of integer overflow. So it looks like this problem was a little bit more challenging. And so for an explanation of what integer overflow is and what it means, why don't we go now to Moshe, if you'd like to talk us through this question.
For sure. Yeah, so this problem happens because you're recording a number in binary, right? And you have a certain number of bits that you're recording them. And an integer would usually be 32 bits, right? So you can kind of turn the bits off or on so that you can get up until a very large number and have 1, 1, 1, 1, 1, 1, 1. But what happens once all your bits are ones? What happens if you want to increment to just one number larger? Well, then you can maybe turn off a bit, but then you'll be repeating some of the numbers from the beginning. So you're limited in how large of a number you can record.
All right, thank you for that explanation, Moshe. Looks like quite a few people have gotten all 5 questions correct so far in a tie for first place. And let's go now to question number 6.
All right, number 6. In C, what character is used to signify the end of a string? In C, what character is used to signify the end of a string? Is it a period? Is it \0, \n, or a semicolon? You should see all 4 answers on your device. All right, time's just about up. Looks like 65% of you correctly answered \0. 1% of you said period. 11% of you said \n. And 24% of you said a semicolon. So some decent spread there, too. Can we go, Josh, to you for an explanation of why these are right and wrong?
Sure. So if you recall from C, strings are stored in C essentially as arrays of strings. And so when C is reading a string from memory, it needs to know where exactly to stop reading that. How does it know that? When it sees the null character or \0.
And Josh, can you elaborate on when and why someone might use a semicolon versus a \n instead?
Yeah, so \n is more useful for when you want a new line, for example, as opposed to the end of the string in memory. Semicolon, good question.
Yeah, so when in C might you use a semicolon? Well, it generally completes your thought. So the period was meant to be a bit of a distraction in that we obviously tend to use periods in languages like English to complete our thought. But in code like C, you would typically use a semicolon at the end of most lines of code to indicate that this is now the end of my action. All right, Brian, let's go ahead and take a look at the board here. So we're starting to see some spread, though still quite a few people are atop the list with 6,000. And that brings us next to question 7 and Brian.
So question number 7. What is the running time of binary search on a sorted array with n elements? Is it big O of 1, big O of log n, big O of n, or big O of n log n? What is the running time of binary search on a sorted array with n elements? All right, let's take a look at the responses. It looks like 56% of people gave us the correct response, which is big O of log n. And a fair number of people, 32%, said big O of n, 8% said big O of n log n, and 4% said big O of 1. And so to talk about this, what these big O's mean and why we know what the big O of binary search is, can we now go to Phyllis?
So recall that in class, in order to illustrate binary searching, David tore apart half of a phone book each time we made a pass. So if we're making a search through n entries, we can essentially throw away half the entries at each pass. And then after that, we will only have to make log n passes to find our desired element. So we can see in this graph where the log n runtime is a lot faster than n or n over 2, which are constant runtimes.
All right, thanks so much, Phyllis. Let's take a look at the leaderboard after the end of question 7. Looks like still quite a few people have gotten all 7 correct. It looks like by my count, about 9 people or so far have a perfect score of 7,000 points, but many other people that have answered all 7 questions correctly as well, maybe just not quite as quickly. So with that, let's go ahead and move on to question number 8.
All right, this is a historical one. What insect did famed computer scientist Grace Hopper find inside the Mark II computer, an early physical example of a computer bug? Moth, fly, beetle, or cricket? And this is a very real question and a very real mythical story in computer science. All right, time is up. Looks like 45% of you answered correctly moth. There were a few other bugs that, to our knowledge, she did not discover inside of that computer. But let's have Josh speak to exactly why we're even talking about bugs in the first place.
Yeah, so Grace Hopper discovered a physical moth in the workings of the machinery of the Mark II computer. And so this is an early example of what we now call a computer bug, but in this case, it was actually a physical one, which is pretty funny.
And what you're seeing there is a photograph of her journal and the actual insect taped to it. Let's take a look at the leaderboard. All right, bit more movement, a bunch more 8,000s, but a bunch of people clipping at their heels. But again, now do your best to buzz in as quickly as you can, not only as correctly as you can. All right, Brian, up to number 9.
All right, let's go now to question number 9. Question 9 is, why might a recursive function without a base case cause a program to crash? Your options are dereferencing null, integer overflow, stack overflow, and out-of-bounds error. Why might a recursive function without a base case cause a program to crash?
This is an interesting one because I think, Brian, we've seen a couple of these answers before, so I wonder if either will be correct this time.
And let's take a look at the responses. It looks like 62% of people gave us the correct answer, which in this case was stack overflow. We had a good number of people say out-of-bounds error. 13% said dereferencing null. 5% said integer overflow. So for a look at recursive functions and why they might crash, Phyllis, could you give us an explanation for this question?
So if a recursive function doesn't have a base case, it will end up calling itself over and over again, leading to infinite recursion. And each time the function is called, stack space, or the block of memory we use to store temporary data, must be allocated in order to store the variables and execute the function. So with infinite function calls, we'll eventually run out of stack space, leading to stack overflow.
All right, thanks so much, Phyllis. Let's take a look at the leaderboard after question number 9. Looks like we still have a 6-way tie for first place, but many other people that have gotten lots of questions right so far. And we still have more than half of the questions left to go. So even if you've missed a couple so far, still plenty of opportunities to get more questions correct. And with that, let's go on to question number 10.
How about a more colorful question, Brian? When describing a pixel's color using RGB, what color would 00FF00 represent? Is it green, red, blue, or black? When describing a pixel's color using RGB, what color would 00FF00 represent? Let's take a look. And in fact, green is correct. Green is correct. And why is that? Connor, could you explain?
Yeah, of course. So as you can see in this diagram here, that six-digit string is actually split up into 3 sets of 2 digits each. And each of those sets can range from 00 to FF. And they're both written in hexadecimal, where 0 is the smallest and FF is the largest. And that first set represents red, the second one represents green, and the third one represents blue. So as you can see in the final row of this visual here, when we have no red and no blue and FF, which is the highest green, the pixel or the color is going to be completely green.
Indeed. Well, thank you to Connor. And if you have programs like Photoshop or you like HTML and making web pages, you can actually tinker with all 3 of those values if you want manually to see what kind of colors you can come up with. Of course, there's also online tutorials that can tell you as well. All right, Brian, let's take a look at the leaderboard. And now we've broken 10,000 with this, our 10th question. Again, it looks like we have 6 people tied for 10,000, which means they're buzzing in not only correctly, but also quite quickly. And it's fine. It's not a competition time-wise. All the better if you can just get things correct, even if you need all 30 seconds. But do challenge yourself with these next 10 questions as things get a little more interesting. Brian?
All right, we're now at the halfway point of the CS50x quiz show, and it's time to take a look now at question number 11. Question number 11, which of the following is not a primitive data type in C? Char, float, string, or double? Which of the following is not a primitive data type in C? All right, time's up for question number 11. And it looks like 73% of people gave us the correct answer of string. 14% said double, 9% said char, and 4% said float. So string is apparently not a primitive data type in C. So if that's the case, Josh, what is it?
So a string is defined in CS50.h, which is why we always include that at the top of our C code. But as we learned midway through the course, it's essentially an alias for a char star, or a pointer to a character in memory.
All right, thank you, Josh, for that. And so that's why if you've been using string in any of your programs early on, that's part of the CS50 library. It's not part of C itself, and it's really just a pointer to a character. Let's take a look at the leaderboard after the first 11 questions. Looks like we still have that same 6-way tie for first place. And now let's go ahead and move on to question number 12.
A little CS50 specific. How would you represent the decimal number 50 in hexadecimal? Is it OX4A? Is it OX32, OX50, or OXFF? How would you represent the decimal number 50 in hexadecimal? Recall that hexadecimal is another base system. In CS50, we start the semester talking about decimal, with which you and I are probably quite familiar, but also binary. But then later on, do we introduce hexadecimal? And let's see how this plays out. Taking a look at the results now. And it looks like 59% of you guessed correctly that 50 in hexadecimal is OX32. Now, this is perhaps rather non-obvious at first glance. So, Moshe, can you enlighten?
For sure. Yeah, so the OX signifies that we're going to do it in hexadecimal. Now, usually how we would count in decimal, we would go with the first places for units of 1, and the second places for units of 10. So it multiply 3 by 10 and 2 by 1. But since we're doing hexadecimal here, we're counting in base 16. So the units place stays for units, the second place isn't for tens, but for 16s. So we're going to multiply 3 by 16, getting 48, then 2 by 1, getting 2, and then add 48 plus 2 and get 50.
Wonderful. And we could do this all day long because we can use any base system in the world to count this high or higher. But that then is hexadecimal. Thank you to Moshe for that question. All right, taking a look at the leaderboard now, it seems that one of our top 6 contestants wasn't quite quick enough to retain all 1,000 points this time. We now have 5 people atop the list with 12,000 points. And on to then question 13.
All right, question 13 is what can cause a memory leak? You have 4 options. Option 1 is someone losing their train of thought mid-sentence. Option 2 is running Valgrind too many times on the same program. Option C is creating so many variables that the computer runs out of memory. And finally, forgetting to free memory that has been dynamically allocated. Which can cause a memory leak? All right, time's up for this question. Let's take a look at the responses. It looks like 77% of people say that what causes a memory leak is forgetting to free memory that has been dynamically allocated. That's correct. And Moshe, could you explain to us what that means? What does it mean to dynamically allocate memory or to free memory, and why can that cause a memory leak if we're not careful?
For sure. Yeah. So when we're running the program, we need well, when we're running C, we need to kind of sometimes we need to allocate memory while the program is running. So this could happen when we don't know in advance how much memory we'll need. This allows us to decide on the spot how much we'll be allocating. But if we forget to free it and we keep on allocating more and more and more and more, we're going to end up with not enough memory to run the program anymore and no more RAM, which is why we always free memory that we have allocated.
All right, thanks so much, Moshe. Let's take a look at the leaderboard at the end of question number 13. So here it is there. Looks like we still have a 5-way tie at 13,000 points. And let's move on now to question number 14.
So if you've taken CS50x in recent years, you might have a leg up with this one. In addition to CS50 IDE's debugger, many CS50 students find it helpful to consult one of these when debugging. Is it a gummy worm? Is it a teddy bear? Is it a goldfish? Or is it a rubber duck? In addition to CS50 IDE's debugger, many CS50 students find it helpful to consult one of these when debugging. If you've not taken CS50 in a few years, this is a real question and a real thing these days. And it looks like 78% of you have been listening and watching closely in recent years, and indeed a rubber duck seems to be the correct answer. But why? Well, there exists such a thing in the world called rubber duck debugging. If you Google it, you can see a whole Wikipedia article on this. And what's pictured here is CS50's own rubber duck that we tend to make available to students on campus and off. And this is really just a proxy for having an actual human available to talk to. If you find yourself running into a bug and not quite understanding how you can solve some problem, quite often it's helpful to talk it through with someone else. But if you don't have someone else in your household or school who's comfortable with computer science or can see the problem yourself, quite often is it helpful to instead just talk to a rubber duck, or really you can use any inanimate object at home, so that you hear yourself walking through your own code and your own logic and thought process logically. And odds are, if you can take this exercise seriously, at some point you'll realize, oh, I didn't mean to say that, or oh, there's the flaw in my logic. And quite helpful, just hearing yourself walk through a solution or a buggy solution will help reveal a solution to your actual problem. So even if you don't have a duck handy, try this with a human or non-human alike. Well, let's take a look at the board, Brian. The leaderboard with those same top 5 atop the list. And indeed, everyone is ranked here ultimately. So not to worry if you're not appearing among the top 10, but we'll keep things interesting and see how many folks end up with a perfect score at the very end too. But let's do that by way of question 15 next.
All right, question 15 is, what's an advantage that an array has over a linked list? Is it that arrays allow insertion of elements? Arrays allow deletion of elements? Arrays allow linear search? Or arrays allow random access? What's an advantage that an array has over a linked list? All right. What's the advantage? It looks like 69% of participants gave us the correct answer, which is that arrays allow random access. And for an explanation of what that means and why that's an advantage, can we go to Phyllis?
Yeah, so recall that linked lists are data elements connected via pointers. So in order to access an element in the linked list, we have to start from the first node and traverse through all the pointers, leading to linear time access. However, to access an element in an array, we can simply use the indices shown, which gives us constant access.
All right, thanks so much, Phyllis. Let's take a look at the leaderboard after this question. A little bit of movement. Some new people have now entered the top 10 that weren't in the top 10 before, so congratulations to you. And we have 5 more questions left in the CS50x quiz show, so let's go on to question number 16.
All right, let's stay on this topic of data structures and ask you now, what's a downside of the trie data structure? About midway through CS50, we introduced tries that might take up a lot of memory, or tend to have a large big O running time for lookup, or don't allow adding new values, or don't allow deleting values. Which of those is a downside of the trie data structure? And if you don't quite remember what a trie is, we talk about it in the context of trees and hash tables and more sophisticated data structures partway through CS50. All right, let's take a look at these results. It looks like 54% of you, so just over half, indeed got the right answer that tries tend to take up a lot of memory, but it looks like the other response below it was almost just as popular. Let's go to Josh to tease these two apart.
Yeah, so as you probably recall, each node in a trie is actually an array. And so each node of those arrays is itself an array, and so forth. While we may not need each element of each array, they all must be present, and so that can take up a lot of space. At the same time, if we're looking for a specific thing So for example, if we have like a search term that we're going through, then we can access with close to constant access going through these arrays based on the indices. So for example, if we have hello, then we would look at H, and then E, and then L, and O. But again, that takes up a lot of space.
All right. Thank you, Josh. Let's take a look then at the leaderboard here. We now have, wow, guest 168 has taken the lead in first place with all 16 questions right, and quite quickly so. Still an opportunity for other guests to nudge them out if they take a little too long or guess a little too incorrectly. But let's now transition to the last 4 questions of the CS50x quiz show. Back to Brian.
All right, question number 17 is a true or false question. Values in Python don't have data types. True or false? Values in Python don't have data types. CS50, of course, begins the semester in C, but later on in the course we transition to talking about Python and some of the differences between C and Python. So is this true or false? Values in Python don't have data types. Let's look at the answer. And 69% gave the correct response, which is that false. It is not true that values in Python don't have data types. And Moshe, can you explain to us why that's the case and why 31% of people might have thought that values in Python didn't have data types?
Yeah, that's a trick question because it's so cool. Anyway, so we don't specify explicitly what data type the value is, or the variable is, but actually under the hood, Python does all of that. So another cool fact is that Python has floats and ints and lists and strings, but it does not have chars. So whenever you have a char, you're actually using a length 1 string, which is pretty cool.
All right, thanks so much, Moshe. Let's take a look at the leaderboard now. Looks like we have a little bit of movement. We have a tie for 9th place now on the leaderboard between guests 216 and 168, with just 3 questions left to go in the quiz show. So back to David for question number 18.
All right, how about a question that we don't teach in CS50, but you can perhaps think back on movies you've seen in your life. Which was the first feature-length film that was entirely computer animated? We, of course, talk in CS50 about applications of computer science to other fields. So which of these was the first feature-length film to be entirely computer animated? Snow White and the Seven Dwarfs, Toy Story, Shrek, or Mulan? One of those was entirely computer animated and was the first film to be so. Let's see the results. All right, it looks like 69% of you knew correctly that Toy Story was the first feature-length film to be entirely computer animated, an amazing application of CS to the real world. Connor, how did this come to be?
Yeah, so it was in the 1990s that this movie came out, and in order to get this to be completely computer animated, they actually had to, in the Pixar studios, keep 117 computers running for 24 hours a day to render the entire movie. Most animated movies have around roughly 24 frames per second, so you'll see 24 different images for every second of the movie you watch. And each frame took anywhere between 47 minutes and 30 hours to render. And an interesting factoid is that that's actually still the case. When animated movies today come out, despite the computing power improving so much, animators do so much more with the films that it still takes frames an average of 7 to 9 hours to render each.
Consider then just how much sophistication there is in these films versus things like Instagram and Snapchat and TikTok and the like that have filters that do really interesting real-time animations, but on a much smaller scale with far fewer pixels. So Toy Story had that claim to fame. Looking now at the leaderboard, we still have guest 168 with lead with 18,000 points. Still 2 questions remain. Brian, do you want to give us our second to last?
All right, question number 19. Which of the following is not an HTML element? Your options are div, h7, img, and blink. Which of the following is not an HTML element?
Keep in mind, in CS50, we don't talk about all HTML elements, so this one could go a few different ways, I think.
All right, and it turns out there were really 2 acceptable answers here. So 53% gave one of the correct answers, which was H7. 40% gave another correct answer, which is blink. So you often use h followed by a number in HTML when you're describing a heading, like a big title or a subtitle on your web page. And in HTML, those possible values range from h1, which is the biggest of the headings, down to h6, which is the smallest of the headings. But there is no h7. h7 is not a valid HTML element. Meanwhile, blink used to be an HTML element in the early days of the internet, but it has since been deprecated. It's no longer an HTML element. So blink, also a correct answer as well. So either of those was acceptable. Let's take a look at the leaderboard just before the final question. Looks like there's been a little bit of movement. And David, you wanted to say something about HTML as well?
Yes, sorry to interrupt. I was just going to admit that I'm old enough to admit to having used the blink tag in my own personal homepage back when I was in college, and I made what was surely the most horrific looking website with just lots of blinking text to welcome you to my website. At the time, too, I think I probably used another tag called the marquee tag that just scrolls text along the screen, sort of like a movie sign or a stock ticker symbol. This is one of the rare occasions where a lot of humans in the world have agreed that these were bad ideas, and they actually removed them from the language such that they are indeed now no longer with us in the CS50 HTML that we know. All right, our very last question, we thought we would keep CS50 specific. It's been such a pleasure having everyone involved today, and we thought we'd ask in conclusion, what is CS50's mascot? Is it a bird? Is it a cat? Is it a dog? Or is it a duck? Over time, you might have seen evidence of this here and there or everywhere, whether in CS50's own classes or videos or communities online, websites or the like. And in about 5 seconds, we will know, in conclusion, not only who's atop the leaderboard, but what is CS50's mascot. And it seems as though 74% of you claim cat, 23% of you claim duck, and 2% dog, and 1% bird. Cat is, in fact, the correct answer. And I think the origin story here is that some years ago, when we were signing up for a YouTube account and other social media accounts, we needed to provide a picture. And cats, of course, are everywhere on the internet. And this fellow here is a particularly happy cat. And I think we probably chose on a whim to use him as our unofficial mascot at the time. But now, some 13 years later, does this particular cat adorn almost all of our accounts on the internet and is thus our happy cat and mascot in CS50. Well, let's take a final look then, Brian, at the leaderboard. And amazingly, guest 168 is the de facto winner with a perfect score of 20,000 points, followed by 600 other guests, all of them winners today here, because indeed the goal of today's CS50x quiz show was not only to bring everyone together for a bit of fun and reflection around the world, but also to help challenge you with topics you might have looked at, to interest you in topics you might not yet have seen, to remind you of topics that you did see and probably should remember at this point. Well, this was the first ever CS50x quiz show. Thanks so much to Brian and the whole team here. We will see you again soon, and we'll be in touch. All our best from Cambridge. Bye-bye.